Yeah. I need to use that more often.
Need some? Oh, knuckles. That's a good one.
Yeah.
I should put it on my knuckles.
Yeah. Where'd you get this from?
Target.
Okay.
They have to be so Walmart.
So what did happen to your nose?
Yep.
And all that?
Huh?
What does happen on
Yeah.
I've noticed like
That's just dry skin.
dry skin. Okay.
Yeah, my skin gets that dry.
That dollar
So it tastes like
You know where you check out, the checkout closest to like the back.
Yeah.
That one, there's a little section right there where they've got the.
Yeah, I almost need to get a steroid version of that because it doesn't, I can't keep up.
I'll bring
Yeah. So I will tell you all at this point, if you start seeing random red lines on the page, most likely. Yeah, I don't feel it most of the time when they crack originally. So not too bad here and there.
no. Like he has dry skin.
Yeah, that was this morning. So, all right, guys. Questions on the homework before we get started? Because we had most of the assignments that we've had so far, y'all got them done pretty quickly. So, what we're looking at today is parallel and perpendicular lines. Slopes of parallel and perpendicular lines. So if two lines are parallel, their slopes are the same. Two lines are parallel in a coordinate plane. Two distinct non-vertical lines are parallel if and only if they have the same slope. Any two vertical lines are parallel. Now, the reason they specify non-vertical lines, a vertical line is a line going straight up and down, yes? What is the slope of a vertical line? Yes. Straight up and down, what's the slope? Rise over run. 0. This one here, because the rise is 0, the run is any length. Because straight up and down is saying that the run, the length, or left and right is 0, and the up and down, we can say any value, yes? What's 4 divided by 0? So another way to say this is we're saying what times 4, or sorry, back up a step. What times 0 is 4? What times 0 is 4?
That's 0.
Because anything times 0 is what? So what we're saying here is we're dividing both sides by 0, so we get this here. So is it possible to divide by 0? No. So this here, the straight up and down line, is defined to be undefined. The slope of a vertical line is undefined. So any line that is vertical is parallel to any other vertical line because the slopes are undefined, they're straight up and down. Our flat line is when the slope is 0 because the rise is 0, but we have run because 0 over any number is still 0. Now, so for any two parallel lines, so any two lines that are parallel, they have the same slope. The slope of perpendicular lines. Two lines are perpendicular if the product of their slopes is -1. And I believe, because y'all did these in Algebra 1, we said opposite reciprocal. Change the sign and flip it. So if the slope we said was m, its perpendicular slope is going to be -1 over m. We change the sign and flip it. And this works out, because if we multiply these two, m times negative 1 over m, well, that's just negative m over m, yes? Anything divided by itself is what? Or not negative m. It would be negative 1. Now, this works out, because we could say that the slope of this line is negative 2, which means its perpendicular is going to be 1/2, yes? Really, they should be flipped. And if we multiply negative 2 times 1/2, well, that's negative 2 over 2, which is negative 1. So, not wanting to type. We're going to look at this first problem here. Now, this first main problem is determine which of the lines are parallel and which of the lines are perpendicular. Well, if we're going to determine which ones are parallel, which ones are perpendicular, we need to find their what? Slope. So the slope of the line is y2 minus y1 over x2 minus x1. It doesn't matter where we start. We can start out with line A. Yeah. y2 minus y1. So what are the two y values for line A? So A is the one on top. So negative 3, 2, 0, 3. So 2 and 3 are slope, y values of the slope, yes? So we can go 3 minus 2. Could we have said 2 minus 3? Yeah, it really doesn't matter which way we put the y values, 3 minus 2 or 2 minus 3. You just need to pick one and put those in. Now, the way we put the x values does matter. It has to match with the y's. So the y value that we put first was 3. What's 3's x value? And if we'd done it the other way, if we said 2 minus 3, the denominator would be negative 3 minus 0. We just have to keep the order the same. Now, at this point here, is everything in that fraction a number? Do we have any variables? Well, we have m, but we're looking at what? Negative 3 minus 2 over 0 minus negative 3, yes? Are all those numbers? What can we do at this point? We can plug it into the calculator. We can plug it straight in. Because we could change the negative on bottom to plus, but the calculator really doesn't care. Whereas we could plug it as is right there, and it will tell us the answer. If we did this by hand, well, the negative would become a plus. On top, 3 minus 2 is 1. 0 plus 3 is 3. So we have a slope of 1/3, yes? The slope is positive, so that means the line is increasing or going up from left to right. Does that match up with the graph? Okay, that's just a way for us to check to make sure we do have the correct answer, or something that it looks like it should be. All right, let's look at B next. So we need our two y values for this line B. So we can say negative 1 minus 0, or 0 minus negative 1. Either one works. Since I put negative 1 first, because the x value that goes with the y value of negative 1 is 0. So we put it first. And again, at this point, we could plug this into a calculator, and it would give us the answer. Negative 1 minus 0 is 0 minus 2 is negative 2. Negative over negative makes a, so we have 1/2. And it is positive, the line is going up, so we do expect it to be a positive slope. Can we say that line A and B are parallel? Do they have the same slope? No, so they can't be parallel. Opposite reciprocal, so change the sign and flip it? No. Okay, so A and B have nothing besides the fact that there are two lines on the same plane. That's all we can say. So let's look at C. y values. -4 minus -5. So we use -4 first. Its x value is +1, so it goes first. And again, at this point here, you could type everything into the calculator and let it do it for us, especially if you don't feel comfortable with negatives minus all the signs. So the negative on top would be plus. It would be 1. Yes. And y'all remember what the parallel symbol is?
2 lines.
And luckily, they put that symbol in the word itself. Yep. I don't know if they did it on purpose, but a company that did do it on purpose is Parallel. There's a product called Parallel that you can run Apple and Windows software at the same time in parallel with each other. And their company's logo is the symbol for Parallel, and their company's name is Parallel. All right, let's find the slope of the last one. So our 2 points are, so we have -2, 0 as one of the points. So y is 0 minus. What's our other point? -3, 2. This time they didn't make both the points the same color on the sheet, but we're just looking for the 2 points. 0 minus 2 is, here with a negative and negative make a -2 plus 3 is, okay. Well, -2 is not parallel to any of the other lines, right? So we need to see if any of them are perpendicular. So D and B both have 2, yes? One way we can check this is multiply them together. So let's see what 1/2 times -2 is. Well, that would be -2 over 2, which is -1, yes? 2 lines are perpendicular if the product of their slope is -1. So we can say that B is perpendicular to D and C is perpendicular to D. Opposite reciprocal. So if we took 1/2 and flipped it, 1/2 flipped becomes 2. Change the sign and it is -2. For 1/3, if I wanted to find its perpendicular slope, we would flip it and have it as 3 over 1 and it would be negative. So if we had a slope of -3, then it would be perpendicular to A. Questions on any of this here? We're going to do it again. So the first thing we need to do is just to find slope. So we're going to find the slope of each line and then determine which ones are parallel and which ones are perpendicular. So A, the 2 points that it goes through is 0, 2, and -2, -2. So we can say 2 minus -2 over 0 minus -2. Well, the negative on top becomes plus, we have 4. Negative on bottom, 2. And 4 divided by 2 is 2. So if we had a line parallel to A, it would need to have a slope of what? Well, parallels are the same. So if we had another line with slope 2, it would be parallel. Now for perpendicular, we need the opposite reciprocal. So opposite means it's going to not be net positive, it's going to be, and reciprocal, we flip it. So it's going to become 1/2. So we get a slope of negative 1/2, we know it will be perpendicular to A. Questions on this so far? Okay. Let's move on to line B. 3 minus negative 1. 0. In the numerator, negative makes a plus, so we have 4. 2 minus 0 is 2. And we get a slope of 2, yes? Can we say anything so far? A is parallel to B. Most likely. C. So we could say negative 1 minus 2, or we can do 2 minus negative 1. It doesn't matter which. Since we put negative 1 first, 3 has to go first. So 3 minus 4. 1 minus 2 is negative 3. 3 minus 4 is, which gives us a slope of positive 3. Well, that doesn't match A and B, as we kind of could tell. And it's not perpendicular, because the perpendicular slopes for A and B would be negative 1/2, yes? What would this perpendicular slope for C be? So we would flip 3, yes? And if I flip 3, it becomes 1/3. And we have to change the sign, so it would be negative 1/3. So if we had a slope for line D that's negative 1/3, then it would be perpendicular to C. But if we get a slope of negative 1/2, it'll be perpendicular to A and B. Yes. So if it started out as a negative? So here, negative and negative make a. Now, that's a good point. So if it's, let's just say it was negative 3. Yes? So we would still flip it. It would become 1/3. And since it was negative, it's now positive. Yeah, so if it started out negative, its reciprocal would be 1/3, and we would change the sign to make it positive. So let's find the last one. Line D. So our two y values are, so negative 3, 0, and 0, negative 1. So negative 1 minus 0 over so I put negative 1 first, its x value is 0. Yeah. Negative 1 minus 0 is negative 1 plus yes. C is perpendicular to D. I think it's just taking your time and doing this step by step. Parallel is the same, perpendicular is the opposite reciprocal. One way that we can always check it is if we multiply the two together for perpendicular, we get negative 1. The product of perpendicular slopes is negative 1. Questions on this here? And again, I want to do this again so that we get used to seeing this and doing this. Yep. We can look at line segment A first. So the y values for line segment A are 2. So we can say 4 minus -2. And -4 minus -2. Negative on top, so 4 plus 2 is 6. On bottom, we have -4 minus -2, which is -4 plus 2, which is, and 6 divided by -2 is -3. So if we had a line parallel to A, its slope would be -3. If it was going to be perpendicular, opposite reciprocal, it'd be 1/3, because we change it from negative to positive and flip it to make 1/3 perpendicular. So if it does help to kind of write out what the perpendicular slope would be as a reminder, you can do that. That way, when we start looking at the perpendicular lines, we can easily, or more easily, figure out which one's perpendicular. Line B has 2 points, 5, 7. Actually, it has 4, because 5, 7 is going through this line, yes? 6, 4 is going through this line. 7, 1, and 8, -2 are all contained on that line, yes? You just have to pick 2 of them. No. 5, so 7, 1, 5, 7. Because 7 minus 1 is 6. 5 minus 7 is -2.
3, so line
A is parallel to B. Because even if we did 5, 7, and 4, 6, or 6, 4, because 7 minus 4 is 3, 5 minus 2 is 1, so we still get -3. No matter which ones we pick, it'll still be the same. Because slope is just the rate of change, and the rate of change between any of these points will be the same. All right, so let's look at C. So 6, 4, -3, 1. So we can say 4 minus 1 over 6.
Does it matter?
So having the -3 first. So if we went 1 minus 4,
Put the 6 minus at top.
it would, because it's going to be the change in y over the change in x. So y values always go on top. Now the numerator, 4 minus 1 is 3. Here the negative make a positive. So 6 plus 3 is so C is perpendicular to A, C is perpendicular to B. Because A and B are parallel, and if C is perpendicular to one of them, it has to be perpendicular to the other. We're still going to go on and find the slope of line segment D. Odds are it's not going to be parallel or perpendicular to either of them. So we would have -2 minus -7 over 8 minus 0. Well, on top, negative makes a positive. -2 plus 7 is 5/8. That doesn't simplify. It's not the same as it are either any of the other two slopes. Yeah. Or it's just hanging out down there. Yep. Any other questions on any of this here? Any questions on anything we've done so far? What we're going to do next, and we're going to finish this up on Monday because we still have several that we're going to do, are these here. Write an equation of a line passing through the point -1, 1 that is parallel to the given line. All we're doing is finding the equation of a line that's parallel to the given line. And one of the equations that we're going to use is point slope. Is this here. y1, x1, the y1, x1 are just a point. That is just a point we're going to plug in. The x and y that don't have the 1 is our input-output. The x without the sub-node of 1 is just the input values where we plug the values into for x. The y without the subnode of 1 are the output. And m is the slope. It's literally called exactly what it is. Because it's an equation of a line, that's y and x, that has a slope and a point. It's point slope form because it has a point and the slope. And it's probably not been brought up or addressed much, but have y'all ever wondered why they use m for slope? Because again, a lot of geometry in our mathematics has come from the Greeks and Arabs, Arabic nations. And in the Greek, they don't say slope because that's an English word, but for rise or increase is montagne, where we get our word for mountain. And montagne is, and that's the best explanation I've heard for M, is because again, it's where we got most of this from, is from Greek and Arab nations. They're very advanced, and the Arabics were actually more advanced than the Greeks in a lot of ways. Yep. And that's actually where we get algebra from, is algebra.
I know we were going over,
Yep.
We were going over, and they were taught, Ms. Hardin said that all the notation.
Yes. They do. And algebra means to complete, I believe. Now, this here is easier than it looks. Now, we're running a line that's parallel to the given line, yes? Parallel lines are what? They have the same slope, yes? So they gave us this equation here. What's the slope of this line?
Good question.
Because the general form of line is y equals mx plus b. So what's in the place of m? So the slope of this line is, and we want these lines to be parallel. So parallel lines have what? The same slope, yes? So our new line's m value is 2. Questions on how we found the slope of our new line? So b is -3, but here, the only thing we care about is these two lines being parallel, yes? So I find its slope. After that, we don't care anything else about that line. We just want its slope. Because here, since they're parallel, the slopes are the same. If they were perpendicular, the slopes are going to be the opposite reciprocal. So we would change the sign and flip it. Now they told us this goes through where? -1, 1, yes? And this is always coming in the form of x, comma, y. So I'm going to plug the x and y value in. Any questions on this so far? Are we following along so far? Yes? Get y by itself and we are done. So the first thing we're going to do is multiply through by 2. So we're going to say y minus 1 is equal to 2 times x is 2 times, well, here the negative and negative make a 2 times 1 is plus 2. Questions on this so far? Is y by itself? So what do we need to do? Y is equal to 2x plus that's it. That is it. Questions on this here? Yep, just give me 1 second.
What?
2x minus 3, 2x plus 3. Yeah. So this here is the equation of the line that we started with. Now we wanted it to go through the point -1, 1. And it found our new equation, 2x plus 3. And that's our new line. Now, you're not going to mess with most of these here. Yeah. Or just trace. So, let's see. Come on. Yeah. Almost right there. Let's graph. And for the second line, I'm going to have to get back to it. Desmos would have been a little bit easier to use with this here. X value is -1, Y value is 1. So what we have is the graph. Now